So as I was saying, do not despair. I will drop your, lowest, I will replace your final exam grade for your test 1 grade if it's helpful, right? So if you're out of class, I was just talking to the class about that for a little bit. And these are the recommended homeworks from section 2.1. If you don't have the textbook for some reason, or if you just want to double check that your version of the textbook is the same as these problems, you can come to my office hours. I'll let you look at that after class, whatever. It's all good. So with that, let's continue on in the material. So I don't know if you noticed or not, but I cut off the end of the class that I gave last time. I talked about even and odd functions, but when I did that, I neglected to pan over. So I'm talking for 5 minutes at the end of last class and then the board is never shown. So I just cut that from the video. So I need to go back to that material. I hope you won't be offended. So here's the definition. If f is function on the reals, and whenever x is in the domain of f, minus x is in the domain of f, then we define, number 1, f is even function. And that is, what's that mean? That means f of minus x is equal to f of x for all x in the domain. Two, f is, I guess I'm missing a word there, is an, right? Sorry, is an odd function. How do we define that? F of minus x is equal to minus f of x. Again, for all x in the domain. So this is the definition of even and odd functions, all right? And so I gave you a couple of examples, right? So we could let f of x equal to, say, x to the 10th plus 2, something like that, right? And we could notice that the domain is what? What's the domain of this function? What's our custom? If we use a formula, we say it's the biggest domain possible, right? So in this case, all reals, right? The domain would be all reals. And notice f of minus x is equal to minus x to the 10th, right? Plus 2, which is equal to x to the 10th plus 2, because minus x to the 10th is what? Do you guys know why that's true? Should I break it down more? I mean, we can. I heard a no and I heard a yes. Well, sorry, Mr. No. I'll have to go. So laws of exponents, right? Because minus x is what? Minus 1 times x, right? So to the 10th power, we get minus 1 to the 10th times x to the 10th. But what is minus 1 to the 10th? It's what? It's 1, right? Yeah. So this is just x to the 10th plus 2, which is, by the way, f of x again, right? So thus, f is even. It's an even function. Let me talk about the graph of this function momentarily here. So it's got a y-intercept of 2, right? And if we were to plug it in our graphing calculator or whatever, it would look something like, kind of like a goalpost. it's steeper than like a quadratic graph. But it roughly speaking looks like that. And so the evenness, what that means is like if you take a point here, which would be what, something like x comma, x squared plus x. Listen to me, x squared, x to the 10th plus 2. Then if you go back over here, there's another point on the graph, symmetric about the y-axis, at minus x and the same y value, right? So geometrically, what it means for a graph, for a function to be even, is that its graph is symmetric about the y-axis. For every point on the right, you've got a corresponding point on the left, just a mirror image over the y-axis. Example 2, we could look at something like f of x equals to x cubed, right? So then f of minus x is what? Minus x cubed, right? But again, same algebra. This is minus 1 times x cubed, which is minus 1 cubed times x cubed. But what's minus 1 to an odd power? Negative 1, right? So this is minus x cubed, which is minus f of x, right? So thus, f is odd. So that's an even function. Here's an example of an odd function. What's the graph of this odd function look like? Do you guys know what the graph of a cubic looks like? It's just like a parabola. It's kind of just like a parabola, but you've got one side of it turned down and the other side of it turned up. That's kind of sort of what it is, but that's not entirely accurate, but it's not far from the truth, so I'll allow it. It's steeper than a parabola, right? I mean, we could throw some points in here to be more descriptive, right? Like, it goes to the origin. What happens when it's at 1? It goes to what? X equals to 1 gives us what? Y? Well, the y-intercept is 0, right? X equals 1, we're like here, right? X equals minus 1, so like 1, 1, 1 is over here, minus 1, minus 1. But if you keep going, I don't know if I've got room. I'm not sure I've got room. By the time we get to 2, where are we? What's 2 cubed? Right, 2, 8. Like 2 cubed is 8. And down here, if we got all the way to, it's way down there. It's minus 2 comma minus 8, If I was to graph the, y equals x squared on the same plot, by the time we get to 2, x squared is only at like 4, right? So it's only half as tall if we go that far. Here, like, x squared is only like half as tall. It's like here and here, roughly speaking. So like, if I was to foolishly plot x squared on top of this graph, it would... Good grief. All right, let's try that again. So x squared should be under this. Well, no. It's a good question. Which is above and which is beneath? I think, I'm not doing a very good job of picturing right now, but I think x squared, that's my question. Is my graph correct? Is the red line beneath the black line? Is that right or wrong? What do you guys think? So if the black is y equals x cubed, right, and the red is y equals x squared, how do we decide whether or not my picture is legitimate at the moment? What would you do? Plug in what? Plug it in a calculator. Hey, that's a good answer. How about we plug in a half? What happens when we plug in like a half? What do you get? Right? So which is bigger, a quarter or an eighth? Yeah, a quarter is bigger. So that my graph is right. It's just not, it's not very pretty. But it is true that x squared is above x cubed right until you get to 1, at which point x cubed wins past that point, and it's always bigger than x squared going on. Anyway, getting back to my example, sorry, I got distracted with the graphing here. What did we find? We found that f of x equals x cubed is an odd function, right? And let me just draw its graph again over here. So what's the deal with an odd function? What's its graph look like? It's not symmetric in the same way as an even function, is it? So people say that a graph with this kind of symmetry is reflected through the origin. You can kind of imagine taking that picture and kind of like flipping it over and down. It's the same shape, it's just turned over and down, right? So this is called symmetry about the origin. And I think what I told you last class is like the name even and odd, it makes a lot of sense if you just think about, like more generally, you could look at f of x equals, like, say, x to the n, and it would be an even function for n even, as in like an even number, and it would be an odd function for n odd. So that actually tells you a lot about how to graph f of x equals x to the n for even and odd, right? So you guys know how to graph x to the n for n even and odd? Like we use our calculator? I mean, that's okay, but these are things that it's much faster if you know how to do it by hand, right? Like in the midst of a test, if you have to pick up your graphing calculator to graph y equals x squared plus 1, that takes a fair amount of time. If you ask me to graph y equals x squared plus 1, I can just do it. All right, we'll do more of that, but let me focus on the task at hand here. So I just wanted to complete what I started talking about last time. Now that I've done that, I'm going to go back and focus more on what's called evaluation of the function, and I'll look at some problems that are kind of like this recommended homework, okay? So you remember we talked about evaluation of a function. What would that mean? Did I talk about that yet? I think I did. You don't remember? Well, let's just talk about it again then. Given formula f of x, we say f of 2 is evaluating f of x at x equals to 2. In other words, evaluation is just like a word for saying you plug in the value into the function, all right? But we don't just plug in numbers, we can also plug in expressions. So just an example to get us started here. Let's say we had f of x equal to the square root of x cubed plus 8, like that. All right? So we could do some things, like evaluate the function at x equals to 1 and minus 2 and a plus h, if possible. So, all right, so like x equals to 1, let's look at that one. What would f of 1 be? Square root of, yeah? 1 cubed plus 8. Very good. And what is 1? Oh, 1 cubed is 1. 1 plus 8 is? The answer is 3, right? So square root of 9, which you guys told me is 3. Hooray. Yes, very good. How about x equals to minus 2? F of minus 2. What happens to us there? Well, minus 2 cubed, right? You're fine. What is minus 2 cubed? Right? So what's the square root of minus 8 plus 8? What's the square root of 0? It is 0, right? Hooray. All right, so that one, again, was possible. I was trying to make that not possible. I failed. What would have happened if instead of putting minus 2, I'd put minus 3? What would have happened to us there? If we'd tried minus 3, what would have happened? Yeah. Cube root of minus 3 cubed, right? Plus 8, which is what? Minus 27 plus 8, which would be the square root of, what, minus 19? And this is not real, right? And so what that shows me is that this shows that minus 3 is not in domain of F. Right? So we can only evaluate points inside the domain, right? Of course, we can also evaluate expressions. And when we're evaluating an expression, we don't really worry too much about whether or not that fits inside the domain. We just kind of do it, all right? So what do I mean just do it? We just follow the pattern, right? So like x equals a plus h, what's that going to look like? F of a plus h. I got to do cube root, right? I do a plus h, I cube it, and then I add 8. And then what? That's right, that's it. We're done. Because I didn't say anything. I just said evaluate. I didn't say evaluate and simplify. If I said evaluate and simplify, well, then it's debatable. We might still be done, actually, because you can't really simplify that. I mean, the only thing I could do in terms of modifying the expression to something else interesting would just be to like expand the cube. But when I do that, I'm still stuck inside a square root, so I can't get out. You know? There's no nice way to simplify a square root unless the inside of the square root is like a square. Then they can annihilate in the flash of pure algebra, leaving us the inside. But yep. All right, let's do some more of these. So I should introduce a couple things to you, right? So definition, the difference quotient, so given f of x, you can calculate f of a plus h minus f of a divided by h. This is called a difference quotient. Or the other kind of difference quotient people calculate is often f of x minus f of a over x minus a. Like those are the sort of your two flavor choices, if you will. There's your Coke, here's your Pepsi. I got no like Dr. Pepper or anything to share with you. Don't worry, it's just Coke or Pepsi. These are the two ones we typically use in calculus. Well, anyway, so this is the difference quotient, and so basically this is a thing you can do that involves taking a given function and evaluating the function and doing some algebra on it, which makes it kind of an interesting testing ground for us as we're learning evaluation. That's all. Right, so that's one thing we can do. So let's do it. I'll take a example. Let's let f of x equals to 3x minus 2. Let's calculate difference quotient as above. So I'm going to calculate f of a plus h minus f of a over h. So how do we do that? What is f of x equal to 3x minus 2? What does that mean? We do what? We take the input, we multiply it by 3, and then we subtract 2, right? So the input is a plus h. So we do 3 times a plus h minus 2. And then it's really important to put parentheses for the second term, otherwise you'll make mistakes. So like minus, I'm going to use some bracket parentheses. F of a, what's f of a? F of a is 3 times a minus 2, all divided by h. Oh, and I forgot to complete my instructions. Let f of x be this, calculate the difference quotient as above, and simplify. So if and simplify is tacked on to the instructions for a problem, well, then you got to simplify. But if I don't put simplify on the instructions for problems, then I may not want you to do it, and it might be horrible to try. So, but this one's not bad. This one won't be bad. Let's simplify. What happens here? We've got 3a plus 3h minus 2 minus 3a minus a minus 2. What's minus a minus 2? Mm-hmm. No. We've got minus times, we got minus a minus 2, which is, well, you're right, it works out to 0, but I'm fishing for plus 2 here. I'm just distributing. I'm sorry, guys. Let me just write it down and say, do we agree? Now, you're right. The 2 and the minus 2 cancel, right? Super nice. And what else cancels? Yeah, 3a cancels with minus 3a. What are we left with? Right, 3h over h, which is, by the way, equal to 3. Right? Now, when you guys take calculus, of course, you'll calculate these things, and then you do what? You take the limit as h goes to 0, and it gives you the slope of the function at a. But this is a linear function, right? So we already know the slope is 3, and that's why we got 3 here. So it makes sense. But now you're not supposed to know that limiting stuff just yet, right? That's calculus that come later. Let's do another one that's a little bit more complicated, okay? Well, you tell me. I'm going to go over here. All right, so another example. Let's let f of x equals to 1 over x plus 2. All right, find difference quotient in terms of x and a, and simplify. So what I'm trying to say is let's do the difference quotient in the second way. Like, let's look at f of x minus f of a over x minus a. Let's work on it that way and see how that goes. So f of x, well, that's given to us, right? 1 over x plus 2. And how about f of a? What's that? Yeah, we just plug a where x is, right? So minus 1 over a plus 2. And then, of course, downstairs we've got what? We've got x minus a. Now, how are we going to simplify? How do you simplify something like this? Well, I'm going to take a starting step. I'm going to go ahead and put that 1 over x minus a out front. And I'm going to rewrite this as 1 over x plus 2 minus 1 over a plus 2. But I'm going to write them super far apart because I want to give us room to do something. So I'm going to say fill in the blank here and here to make the algebra go. What do you want to do? If you want to combine those fractions, what should we do? Yeah, multiply by 1 in the right way to make a common denominator. So, I want an x plus 2 times a plus 2 for my denominator. So, I mean, this is just kind of like 1/5 minus 1/7, right? So you want to put those together. You multiply the 5th by 7 over 7. You multiply the 7th by 5 over 5. That's the kind of pattern we're looking at here. So thinking of the 7th as like a over 2, I do a plus 2 over a plus 2, right? And then over here, I'll do x plus 2 over x plus 2. And I can do that because I'm just multiplying by 1. And the reason I'm doing that is so that these two fractions have the same denominator, so now we can add them. Right? Created the common denominator that we wanted. And so we've got 1 over x minus a. And so we got what? We got a plus 2 minus parentheses x plus 2 divided by x plus 2 times a plus 2. Does anything cancel now that we've done that? Oh yeah, the 2. You said the 2's cancel, right? And I'm going to write out another step. You might already see it, but this is a minus x, right, over x minus a times 1 over x plus 2 times a plus 2. So you got a minus x, right? What is a minus x over x minus a equal to? How does that simplify? What's that? This guy right here, how does that simplify? If I do a minus x over x minus a, I can rewrite that as minus 1 times x minus a over x minus a, right? So these guys cancel, and it just leaves us minus 1. So see, this tells me that this factor right here is nothing more than minus 1. That does assume something, right? I'm assuming that x is not equal to a. Good news, when you get to calculus and you calculate these difference quotients, that's an assumption you get to make, because when we take the limit as x approaches a, we have x going to a, but x is not equal to a. So like that assumption that x is not equal to a is something that we do have in calculus later when we do this. But anyway, so it's minus 1, right? So end of story, minus 1 over x plus 2 times a plus 2 would be a totally legitimate answer in my book. Of course, you could also multiply that out and leave the answer as like ax plus 2a plus 2x plus 4. I mean, that would be fine. When we say simplify something, there's a certain ambiguity that's involved. Like there can be more than one right answer to a simplify question. When I ask a student to simplify an expression, I'm looking for a genuine effort to like reduce, to make common denominators, to group things together, to look for cancellations when they're readily apparent. And so if you do those things, you'll get credit. Yeah? So any questions? Another thing you can talk about is the average value of f of x for x equals to a and x equals to b, all right? And the way that works is it's equal to f of a plus f of b divided by 2. So that's, that one's actually a little bit easier than the difference quotient, right? So here, let's actually do that. Let's see here. How about f of x equals to 1 over x cubed plus the square root of x. And we can say find average for x equals to 1 and x equals to, 9. So we have to do what? We have to do f of 1 plus f of 9 and divide by 2. So what's f of 1 equal to here? One over 1 cubed, right? Plus the square root of 1. And then f of 9 is, 1 over 9 cubed. Yeah, plus the square root of 9. Yep, all over 2. And so the first thing is easy enough. That's 2. 1 over 9 cubed is 1 over 9 times 81, which is, was that 729? I don't remember. What's 9 cubed? Oh. So don't ask me my kid's birthday, but I, for some reason, have remembered that 9 cubed is 729. Great. Let's see here. Don't tell my wife. Let's see here. So none of you know my wife, though, right? So I'm safe. I'm safe. She doesn't watch my YouTube channel, so we're okay. Let's see here. So I don't know, whatever that is. I mean, it's a big old number, right? So 5 plus 1 over 729 divided by 2. Now, for the sake of me not going nuts when I give the test, I'm probably going to ask you to please give me a decimal answer for this. So what would the decimal answer for this be? Oh, Heaven, you got a calculator. Could you calculate it? Just what is the decimal version of this? Like 5 plus... It's close to 2.5, but it's a little bit more than that. Like, give me like a couple digits past that. 2.5 what? 2.50068. So the reason that so basically, what's going on here is 5 over 2 plus 1 over 2 times 729, right? So 5 over 2 is that 2.5, and 1 over 2 times 729, that's like it's smaller than 1 over 1,000. That's why it's not appearing till like the fourth decimal place, if you think about it, Anyway, there we go, approximately. Okay, so another example. Let's say we've got 3 plus x over 1 plus x squared. Evaluate at, first of all, x equals to 0, and then at x equals to 1 over x. F of 0, I think you guys can do, right? So what's f of 0? I heard 3. So the reason you say 3 is that 3 plus 0 over 1 plus 0 squared, which is otherwise known as 3 over 1, which, as you have already told me, is 3. Hooray. Very good. How about f of 1 over x? And I said x equals to 1 over x, but that's not really what I want to say. X does not equal 1 over x, right? But that's, I want to evaluate x equal to 0 and 1 over x. That's what I should say. What is f of 1 over x? So when we come up against a question like this, when you're first learning, it's sometimes helpful to say the formula for the function in a different variable. Like, if f of x is 3 plus x over 1 plus x squared, I can tell you that f of, let's say, u is 3 plus u over 1 plus u squared. So I can think about setting 1 over x equal to u, So what I'm doing right now, I might refer to as, these are kind of like, when you first ride a bike, you have training wheels? This is kind of like that for a function evaluation. Like, I wouldn't do this anymore, but if I was super sleepy and I just doubted myself, I might do this. I don't know. But here it is, 3, 1 over x over 1 plus 1 over x quantity squared. And there you go. This is f of 1 over x. That's it. Yeah, now if I said simplify, what would you do? If we add the instructions, the dreaded instructions, and simplify, what would you do here? You'd say, I hope you made the quiz too long and you let me skip a problem. This would be the one. Yeah. What do they say in the Hunger Games? About the odds being in your favor or something? I mean, that's true. I often write something too long and I'm not going to do it. Next time I'm going to give you like 2 pages. Just like 4 problems. There'd be no skips. And there'd be no way out. If you don't know something, you'll just be, uh-oh. What's that? We had to skip on the quiz. On the quiz, I let you guys omit 2. I didn't do that? Oh, that's the other class that I like. I forgot.
Wow.
So you don't like it?
Turn off the camera. It's time for my beating. No, no. Oh man.
Just go through.
What? Oh, you guys are right. I'm thinking it's my stupidity. I graded your quiz and also the intermediate algebra quiz right before class, and you, you, you do not want to get in that class. That class will just take your money, but it doesn't give you college credit. It's a bad deal. This one you have college credit for, right? Well, then just don't fail. So. Well, the first step to not failing is to believe that you're not going to fail. Well, all is not lost. Do not give up. Let's see here. So, oh, I'm below the monitor. Sorry about that. So, if I was going to simplify, what I try to do is to remove. I want an answer without compound fractions, right? I want fractions of fractions. So I try to get rid of the denominators, and the way to do that is just multiply this by x squared over x squared. If I do that, then I'll clear out the 1 over x squared, and that'll give me a better answer. Distributing, right? And so that's 3x squared plus x over x squared plus 1. There you go. That's about as simple as I can get. I mean, you could factor an x out of the numerator. But where is a place where you'd want to simplify? The 3? Oh. You're answering my question literally as in terms of like your desires. I get that. But if I asked you a question like, suppose I asked the question, f of 1 over x greater than 0, and I solve that inequality. See, if I did that, right, then there's a place that would give you a reason to simplify, right? Because, if you get to something like 3 plus 1 over x plus over 1 over 1 plus x squared, and you say that's greater than 0, we don't really know what to do. But if I get to something like this, right, and I just simplify it ever so slightly more, and I ask where that's greater than 0, I know what to do. I make a sign chart. I put a tick mark at 0, another one at minus 1/3, and I can solve that using the, solving inequality stuff we talked about before. Some of you need to study before the bonus quiz. Excuse me, most of you need to study before the bonus quiz. All of you need to study before the bonus quiz, I think. Yeah. Whatever you didn't understand on the test, except for the last bonus. The bonus question would not be on. I won't ask anything about triangles. What? The whole test. Well, it's going to be shorter than that, so I'll try to avoid the parts you guys already understand. I'm sorry, I should stop. This is not the humor you need to hear right now. Where is it? I was making some kind of doom and gloom kind of comment, and it's no good. All right, let's go on. So we've talked about domain, we've talked about range, right? But what we really need to get into is how to graph, graph functions, right? And so by the way, I should say that's the average value. There is another average that I have failed to include here. I should distinguish that from, in section 2.4, we'll talk about the average rate of change of a function. That's a little bit different, right? Average rate of change, in contrast, would be this would just be f of a minus f of b over b minus a. So see, that's a little different, the average rate of change versus the average value. Anyway, later. So let me just talk about some example graphs, because these are ones, so what the ones I'm about to show you, I think these are graphs that you should know. What I mean by that is, as soon as somebody writes the formula down, in your mind's eye, you should have like a picture of these graphs, right? You should have a kind of like, oh, I know what that is. That's one of those kind of feeling. And so let me just start giving them to you. So the first one is something like y equals mx plus b, right? You know what that is, right? That's a line, slope m, y-intercept b, right? So we've already talked about that, right? Yep. And the next one I would say is y equals x squared, right? This is a parabola, right? What does it look like? Basically that. Now we could be more detailed. We could throw in some points and do it on graph paper, make it careful. Do it with a calculator. That'll take more time, right? But there's also part 2 of number 2, y equals minus x squared. What's that look like? Same thing, but like that, right? So opens up, opens down, right? 3. How about this guy? Y equals x cubed, right? So that's something we should be able to sketch without actually plotting points, right? You should just be able to kind of like draw it. You can throw in some points if you want to make it more, precise, like I did earlier with the 8 and the 2 and such, right? But that's basically what it looks like. What's it look like with them? What about minus that? What's that look like? Right? What does that y equals x to the 4th look like? Ooh. So again, it's kind of like, I mean, my picture for y equals x to the 4th or y equals x to the 2n, for n equals to 1, 2, 3. Heuristically, that's what they look like. They're not all the same. Like, I'm going to draw all of them on the same graph at once to show you the difference. But generically speaking, like, that's essentially what they look like. They look like just a bowl that opens up. Pretty much. Yep. And, 5, if you have y equals x to the 5th or x to the 7th, generally x to the 2n plus 1, right? It looks like, basically like the cube. Now that's a lie. let me show you why it's a lie. To be more, I mean, I can be more precise, all right? You're like, well, but they're not the same graph, right? That's true. So let's see here. Well, I'm going to focus on the even ones because I can draw those better. What can you say about y equals x to the 2n when x is equal to any of these, any of the even graphs? When we plug in 1 or minus 1, what do we get? We get 1 to the 2n or minus 1 to the 2n. So if you think about that, any of these, when we plug in plus or minus 1, we get 1. So like all of these graphs, they all share these particular points right here. The parabola, what happens when we plug in a half? What's 1/2 squared? It's a quarter, right?
Yes.
So the parabola is like somewhere in here. If I can't draw. So that would be the parabola. What happens with the quartic? I should really just I'm going to get out the projector here in like 2 minutes. I'm just suffering through this to show you that you can. Y equals x to the 4th. What would that look like? What happens when we... So if we put, for this one, if we put x equals to 1/2, what's y equal to? One half to the 4th, which is what? Yeah, 1 over 2 to the 4th, which is 16. It's 1/16. Where is that? I mean, it's like down here, right? It's like much closer. It still has, when you plug in 1, you get 1. So it's still, they all share this common point of 1, 1 and minus 1, 1. So it kind of like, and then what happens when you cross 1? When you cross 1, any number bigger than 1 raised to the 4th power is bigger than the same number just raised to the 2nd power. So they're like, it goes above. And so it's, something like that. And as you go to higher and higher even powers, it kind of blows up more. Like if we looked at x to the 6th, it would look something more like, so that's why I say it's a lie that I said that they all look the same, you know? That's not true, but if you just kind of want like a gross picture of what they look like, it's like that. Right? But the honest truth is that the x squared is like not as, I don't know what the word is. The bowl isn't as deep, kind of. I mean, what do you want to say about the green? How would you describe the green curve as opposed to the blue and the red curve here with words? Maybe you could say that the green curve is more concave or something, you know? So similar statements go for the odd powers. Like the higher odd powers, they just grow steeper and steeper, but it's the same like general shape. The symmetry with respect to the y-axis is the same. All right? So first of all, you know, I know these functions. If I see that formula, I know what the graph looks like. I know, right? And then beyond that, what else do we know? If we have something like y equals to y equals to 1 over x, that looks like this. So it's actually a hyperbola that opens like this, for what it's worth. And if you were to look at like 1 over x cubed or 1 over x to the 5th and so forth, those would actually look kind of similar to those, but those almost never come up. But 1 over x to any odd power looks essentially like that. How about 1 over x to an even power? So I usually refer to this guy as a volcano function because the graph, I can never tell looking back at that if it's actually there or not. The graph looks like a volcano essentially, right? So here, like this. And so the example 6 and example 7 have a new feature that we should talk about in this course. Something happens special on the y-axis. The y-axis is what? What's called a vertical asymptote, which we can abbreviate VA for vertical asymptote. Vertical asymptote is like a vertical line that the graph gets close to, but it doesn't actually get to. So like the domain of the function, if we think about the function f of x equals 1 over x or f of x equals 1 over x squared, the domain doesn't include 0, right? So sometimes when we have a point excluded from the domain, it could be that the graph of the function has a vertical asymptote there. So, and then probably 2 more examples, and I think that's pretty much it for our usual, like these are things I would hope that you could recognize the shape of without having to pick up a calculator. Square root of x, it looks like this basically. Can you guys see that? Heaven, can you see it? Okay. So the square root of x, and if you were to throw in minus the square root of x, what would that look like? Like that, right? And so like, if you look at y equals to plus or minus the square root of x and you square that, what does it give you? Right, because squaring plus or minus gives you plus. Squaring the square root of x gives you x. So if you look at this and that together, what you're actually looking at is the graph of x equals to y squared. It's nothing more than a parabola that opens to the right. So we can understand the square root function as being a close relative to the parabola function. It's just half of the graph turned on its side. So that's a useful thing to know about, but of course this is. And then finally, 9y equals to the cube root of x is something we come across from time to time. And a quick way to understand what that is to do a little bit of algebra. Cube both sides, what do you get? Right, the cube root of x cubed is x again. So this is really the same as the graph of the equation x equals y cubed. And if you think about that, that's just the cubic graph turned on its side. So you can kind of understand the cube root function as just being the cubic graph turned sideways. So oh, there's one I left out. There's one other one I left out. You're like, stop that. No, there's one other that commonly comes up in this course and in calculus also, which is the absolute value function. Do you guys know what the absolute value function looks like? It looks like a V, right? So there's that one too. We'll talk more about that another day. All right, well, I'm going to hit let me get your, you got it?